What follows is an implementation of the classic game rock, paper, scissors in Python. And what your job is to do is to understand how the code works and then implement your own strategy by composing a Python code file that looks something like one of these. All of these are team files that are supplied in the um, downloadable code team 1, team 2, team 3, etc. .py. These are the implementations of strategies to play in this game. Okay, so you're provided with psrock underscore play, which really uses psrock.py to run the game, and you're also provided with 5 team strategies to look at and gain inspiration from. So what I'm going to do is go through the game, the Python game. It's not necessary that you understand 100% of it, but it's a good idea if you understand most of it. And then it's really important that you go and look at the other team strategies and see what they did in terms of developing a strategy in Python, because you're supposed to develop a strategy and then talk about um, the algorithms that you used. So let's look at this psrock underscore play. It's really just a wrapper that uses and calls psrock.py. So if you look at this psrock underscore play, it's only 18 lines long, and that includes a couple of blank lines. So let's see what it does. It imports all the code from the psrock.py file that's right there. And then it reloads it. The whole purpose of reloading it is if it had loaded it before, it'll ignore the command to import it. But if it was changed in any way, none of those changes would be reflected in the new running. So if you reload it, you force it, even if it thinks it has already read it in, to read it in again. And these are team files. If you had a classroom, you'd assign kids to team files, or maybe 2 or 3 kids per team file. So this represents 5 team files, this import statement here. If you got the files from the students, you would have to have them in the same directory as this code is running. And then line 6 through 10 just reloads those in case you had run it before and someone had made changes. It just forces it to read it again. This right here, line 12, is a multiple assignment, so we're assigning short report to something and long report to something, and that something is whatever was returned after we called psrock's round robin method, sending it 20 and the 5 team names. If you look right here at psrock and you look at round robin, it asks for a number of rounds, and here we sent it 20, and then it asks for something kind of strange, this asterisk argv, and that just simply means a variable number of arguments. You can send it 1 or 100 or anything in between, and there is no limit even on 100, but we sent it 20, which was the number of rounds, and then we sent it 5 team names. Okay. And in return, after it does its thing, it's going to send back 2 pieces of information. The first thing is going to get sent assigned to short report. The second thing is going to get assigned to long report. And this is a classic multiple line assignment. So let me show you. If I open up a terminal and launch Python, I can do something as simple as a comma b equals 2 comma 9, and press enter. And then if I say, well, what is A? It says 2, and what is B? It says 9. Because you assigned 2 things at once. The 2 went to the A and the 9 went to the B. That's really all that's happening in this code, is we're calling this round robin method from the psrock file, and we're sending it this information, and in response it's returning 2 things. One goes to short report, one goes to long report. Well, apparently whatever's in long report is an iterable. It could be a string, it could be an array, it could be a dictionary, it could be a tuple, but it looks like in this case it's an array, because if you look at the shaded line 14, that's the structure for an iteration, for looping. So this must be an iterable. I would say it's an array, and this is going to take on each value in the array sequentially until it's done. Line 15, it's going to print 80 hashes or 80 dashes, and then because this is an array and this is the current value in that array, it's going to use that as an index to print the report for that team. And then in the end, it's going to print some sort of summary, some sort of short report. So if I ran this, you'll see, if I pull it up right here, there's the 80 dashes. And then this must be the short report. And if you scroll up, you'll see the long report. So this is a report for Team 2. And then this is going against Team 1. Then this is Team 2 going against Team 3. This is Team 2 going against Team 4. And this is Team 2 going against Team 5. And this shows in the first move was paper, and this one was rock. And since paper can cover rock, Team 2 won that one. Then it was rock, rock. That was a tie. Nothing happened. Then it was rock, paper. So Team 1 got a point. And then this is the name of the strategy, and we have to provide that, and you'll see how we do that in a moment. But it's not going to show you the results unless you have in the window psrock_play.py, and then you press run. But it implements this. Remember, it calls this thing called round robin. So let's check out how that works. Round robin, of course, you get a number of rounds. We sent it 20 and a variable number of arguments. We sent it Team 1, Team 2, Team 3, Team 4, Team 5. So it starts out by creating an empty dictionary called scores and an empty dictionary called report. And if you want to recall what a dictionary is, let's go over here and say, and it's lagging a little bit because of the internet, so let's see if it eventually types. Yeah, my dictionary equals, and I could say name, and I'm typing it, but it's not really echoing it out. There it goes. And then I'm going to say Bill, and then I say age, and it said, then I could say 56. Now if you notice, if I have a string, I have to have quotes in it, so Bill has to have a quote around it. And then if I have a number, it doesn't need quotes. Okay, so now I've created a dictionary that has two key value pairs. One key is name, and the other key is age. Well, the value of name is Bill, and the value of age is 56. So if I say something like my dictionary, and then I say, give me the age, it'll say, should say, as soon as it catches up, should say 56. The network is a little bit slow for some reason. I didn't spell a dictionary right. If you look up there, that's missing a T. So I come back over here, trying desperately to go back over there. There we go. And like I said, the internet isn't working so well. So then it says 56. There you go. So the bottom line is a dictionary is defined by braces, and they use key value pairs. All right, so that was just a little tangent to talk about dictionaries, because we just started two blank dictionaries, scores and report. This is a blank array, right? So it's going to be called team names. And then strategy names is a blank dictionary. Okay, so we sent it 5 teams in the variable number of arguments. Okay, so we're going to iterate through those teams, and each team is just going to be called player 1, and it's going to loop through the variable number of arguments. The first time through, player 1 is going to be team 1. The second time, it's going to be team 2. Third time, team 3, etc. So then we take this current team, which now is team 1, and we call the procedure team name. And if you look up at team name, it just splits what was sent to it on any sort of space and replaces any slashes with an empty string. In other words, takes out all the spaces. So basically what that does, because it sent in the directory information and everything, it just returns the word team 1 or the word team 2, etc. So this is calling the string function from the module. And if you look over here and you look at, you should have a string function. Well, if you don't have a string function, then it's just going to return your location. We could show that, but it'd probably be just a waste of time, so I'm going to skip that. So just trust that team name just returns team 1, team 2, team 3, team 4, team 5. Okay, so that's what that does. It accomplishes that. So team name 1 would be team 1. And it's going to append it or put it at the end of this array, and that array is going to grow. So the first time the 0 element will have team 1, the number 1 element will have team 2, etc. It's just building a list of team names in that array. Not all that complicated. Okay, now each team has to provide a strategy. So if you look right here at team 1's file, the strategy name is called beat last move if repeating. Team 2's strategy is called random. Team 3's strategy is called rock first, then alternate paper and scissors, etc. So what we're going to do is, remember, this player is going through each of the teams that were sent to it, and it's going to access its strategy name. Remember, all of these things had something called strategy name inside them. And so at the beginning, when we imported them, we imported anything that was in that file, right? And something that was in that file was called strategy name. So now we're accessing that strategy name from the current team that we're looping through, and we're adding it to the strategy names dictionary, and we're using the key, whatever their name is. So team 1 is going to have its strategy name, team 2 is going to have its strategy name, etc. And they're going to be keyed off of the word team 1, team 2, team 3, etc. Because it's a dictionary. Remember, dictionaries have name and value pairs. Now the report, if you looked up here, the report is also a dictionary, so it's going to have name value pairs. And so because this team name 1, which remember we called the team name, sending it the current team that we were looking at, was stored in team name 1, so that'll be team 1, team 2, team 3, team 4, etc. That's the key for the report, and it's just going to say win, loss, tie report 4, and then plug in its name, team 1, and then a line feed. So that's going to be in the report dictionary. And then we're going to have an empty list that's going to be stored in the scores dictionary. And again, the key is going to be team 1. So we have scores, team 1, report, team 1, strategy name, team 1, etc. Okay, and now we're going to loop through all of the teams again in that variable number of arguments. So team 1, team 2, team 3. And so we're going to get the name like we did before by calling team name. And then scores team 1, we're going to add to it an X. Okay, so that means we're just going to have, remember, scores up here was a dictionary, and we're going to add to that dictionary, that's what the append means, just the letter X. Okay, now that's because it doesn't have a score right now, right? So then player 2 is going to be where player 1 is right now, plus 1 more. So that's really just saying we're going to get the next player, right? And then this is an array slice that just says go to the end. If there's no number here, it's just going to go all the way to the end. So basically it's going to say player 2 in the list that includes the next player from me, and if I'm player 1, that would be player 2, all the way to the end. So just visualize 5 teams. If I'm team number 1, this line right here says go through all the teams from 2 to 5, because the end of the list is 5. And so we're going to get player 2's name. Now keep in mind, player 2 is first going to be team 2, and then when it's done with the loop, team 3. Then when it's done with the loop, team 4. Then when it's done with the loop, team 5. So this just loops through all the teams. That's why it's called a round robin tournament. You play all the teams. And it gets that team's name. And then here we call this procedure called playoff. and we send player 1's move, player 2's move, and the number of rounds. Now remember, if you look up here, move, that's what it's accessing. So when you say player 1 dot move, you're saying if player 1 is team 1, then run your move, and if you're team 2, well, run your move, right? And we have to send certain things to that. So here, we're going to go look at playoff here in a second, but we're sending the two players their moves actually and how many rounds. Now remember, number of rounds was sent to us, and in the case earlier, we figured out it was 20, right? So we're going to go to playoff. So let's go ahead and scroll upward and look at playoff. It says define playoff, the two players, so that was the first one's move and the second one's move. And the number of rounds is 20, but if you don't provide something, it's just going to default to be 60. That's what it means, equals 60. If you don't send anything, it's going to default at 60. Now, this is saying that record 1 is going to be, that would be player 1's record, 0, 0, 0, and 0, 0, 0 for record 2. And these are tuples, which means we're just storing the number of wins, losses, and ties, or 0, 0, 0 for each team. Okay? All right, so now the history is what their move was. Every time they move, they're going to be given a P or an S or a R. So P for paper, an S for scissors, and an R for rock. And we're going to store that in a long growing string. So the first time, nobody has a history. If player 1 did a P or a paper and player 2 did a S or a scissors, then each of them would have a history, and one would be P and one would be S. If they'd say duplicated their move, history 1 would be P, P, and history 2 would be S, S. So it's going to grow according to what their move is. Okay? So now we're going to loop. This is a looping structure from record number, or round number, which will be 0, all the way up to the number of rounds. Even though it says up in the line 39, it says number of rounds equals 60, that's only if nothing was sent to number of rounds, but we sent 20 to number of rounds, so it's going to go 0 through 19. Because remember, if I say range 20, I'm only going to go to 19. So in line 44, move 1, move 2, new score, is what's returned after we execute the function round. We send round player 1 and player 2, so those are the team numbers, and then their histories, the history of team 1 and the history of team 2. Now, at the beginning, the history is nothing, okay, but we suddenly have to jump to where round is, okay. So round is up here, and it says, okay, if you haven't sent it, the history is nothing. And this is really the move for player 1 and the move for player 2. Okay, so we're going to call player 1, which remember is the move for player 1, and send it its history. And if there is no history, we're going to send it this blank history. And then we're going to send their history, which in this case is the second team's history. We're going to call player 1, which is basically, remember I said that it's really player 1's move. So if we go to team 1 and we look at its move, it's going to send my history, or I'm sorry, it's going to collect or receive the two histories, the self history and the opponent's history. Now let's look at team 1 strategy, okay? So if the length of their history, and keep in mind that's the opponent's history because it says their history, is less than 2, which means we're less than 2 we're actually less than 3 rounds into it because you go 0. Well, no, I'm sorry, it says length, so it isn't the index, it's the length. So if the length is less than 2, that means it has to be 0 or 1. If it's just the beginning or 1 round into it, then we're going to automatically do a rock. Otherwise, if we've done at least 2 rounds, we're going to look at their history, and -1 means 1 from the end. So from the right side, go in 1. So their last move. This means their last move. if their last move was the same as, that's what two equal signs means, the same as, their move 2 moves ago, because -2 means 2 moves from the end. In other words, there seems to be a pattern there. Then what we want to do is figure out what that pattern is and beat it. So we're going to call this little routine here called beat move, sending it whatever their last move is. Now keep in mind, you're not going to call this unless they've done the same thing for the last 2 moves. So the last one and 2 moves ago. So apparently they're setting a pattern. So we're going to call beat move. Well, it goes up here to beat move, and we're going to send it whatever move they've been making. So that's what this is. Well, if they've been making a rock move, then we're going to say send out paper. If they've been making a paper move, we're going to send back scissors. If they've been sending out scissors, we're going to send back rock. And what you'll notice is whatever they've been sending out, we figured out in this routine what will beat them. So then we send that back. So just to reiterate, if there's no history, then we would return a rock. But if there's a history and their last move and 2 moves ago was the same thing, figure out what that move was and beat it. And here it says, if the length is less than 2, we're just starting, so return a rock. Here, if they've set up a pattern, beat their move. But it is possible that not only is it not a brand new game, as 1920 is trying to pick up, or they don't set up a pattern like 21 and 22 is setting up, then let's just randomly choose between one of the R, P, or S's. So, sounds like an interesting strategy. So it's going to return whatever the move is supposed to be. Okay, so here we go. We've called the move and we've sent the histories, and that's what we decided to move. So R, P, or S. That thing highlighted in 5 is going to be an R, P, or an S. The same thing happens for 2, except the context is with player 2. So if we went back to player 2 strategy, it's just called random. So if you call move and you send the 2 histories to player 2, they're just going to pick something randomly between R, P, and S and then return that. So that's kind of a lame strategy, but they're going to do that. And so we have the 2 strategies, and then we got to make sure they're valid, because remember we initially set them to be X's. Okay, so here remember move 1 is going to be a a P, an S, or an R. Move 2 is going to be a P, S, or an R. If they're the same, then we have a tie. Then just assign zeros to each of their scores. If you wanted to see that they both had well, no, I guess I should say this causes the 2 letters to be smushed together. But what they all indicate, the patterns in here all indicate wins on the part of Team 1. Because if you squish them together, if it's RS, then Team 1 won because the rock smashed the scissors. If it's SP, well, Team 1 won because the scissors cut the paper. If it's PR, well, Team 1 won because the paper covered the rock. And in that case, 1 goes to Team 1 and -1 goes to Team 2 because Team 2 lost, Team 1 won. Now, if it wasn't a tie and if Team 1 didn't win, then that must mean that Team 2 won. So we give Team 2 1 point and Team 1 loses. Now that's all based on the fact that these 2 moves were valid. We had to call a procedure called valid to check that. So valid makes sure that there's only one character in the move of the team, and then that character is found in the string RPS. So it's either an R, a P, or an S. If that's true, it returns true. If it's not a length of 1, or it's not an R, P, and an S, then return false. In other words, it's not valid. So we had to do a validity check here at the beginning to make sure that move 1 and move 2 were valid before we did all that code. Now, if they failed the validity test, either move 1 was invalid, or move 2 was invalid, or both of them were invalid. So we have to do an else that says, well, if move 1 was valid, that means it gets a point, because that means that 2 had to be invalid. And then so we're going to check, well, if 2 was valid, then that means 1 was invalid. Okay, and so 1 lost a point, 2 gained a point. But if neither of those conditions is met, that means both of them must have been invalid. So they both get x's as scores, and they both get negative 1s as scores. Well, they actually get x's as moves for their history and negative 1s for their score. And then it just returns the 2 moves and the 2 scores. Remember, this is called round, and round was called down here in playoff. Okay, so since it returned 4 scores, it's going to return the 2 moves, and it's going to return the 2 scores. Okay, you can see after assigning the scores and the move that the history of each is updated. Remember, this says my history 1 is what it was before plus what it is now. And so remember, if there was a move that had more than one letter, move 0 just takes one letter. So the move is assigned to the history, and the history is growing. Okay. Now here is a new procedure, and it's kind of odd that they decide to write it right here. But anyway, if we send in a record and send in a new score, if the new score is negative 1, then if you look here, they're providing the record's value for the wins, losses, and ties. So record is an array, and the array is keeping track of the current record. So record at the 0 position is the number of wins, record at the 1 position is the number of losses, and records at the 2 position is the number of ties. And so if this is a situation where the new score is negative 1, that's a loss. And so the loss position, 1 is added to the number of losses. If it's a tie, because the new score is 0, then the wins isn't changed, the losses isn't changed, but the ties is changed by 1. Because remember, record with an index of 2 is accessing the number of ties. Record with an index of 1 is accessing the number of losses. And record with an index of 0 is accessing the wins. And you can see that in action right here, where if the new score is 1, that means it's a win. And so the number of wins is increased by 1. And so all of those things are called records. So that record is returned to whoever called new record. Well, and then down here we use it. So we call new record, sending the record for team 1 and whatever their score was on this particular round. And so based on this algorithm, we update it. That's a nice algorithm to talk about in your submission, because it's mathematical in nature and it's a pretty easy algorithm to understand. So they call new record, sending it the team 1's record and then the score from that round, and then that's assigned. So remember, a record is returned from that call to new record, and so that updated record is now called record 1, and the other one is called record 2. That's the opponent's record, right? And so this whole function called playoff is going to return the 2 records, which is the number of wins, losses, and ties for each team, and their histories. Remember, it's a string like PSR, 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 RRR, whatever their history was. Okay, so that, remember, we came in here calling round robin, and round robin initialized some things, and finally called playoff, right? Well, playoff right here eventually called round, right? And so round, if I can find it, must be up at the top. Round got the moves from each player. Right here, move. So player is just kind of a placeholder for that move. And it sent the histories of each individual team. And then this move was applied to their each team strategy, and it dictated what their next move was going to be. And so then those moves were compared to see whose move was superior and scored accordingly. And then, of course, their records were updated, because the records get updated right here. We just went through that. So that is a brief look at how this psrock.py implements the classic game rock, paper, scissors.